Every model makes structural assumptions. Those assumptions define what the model can and cannot see. The confusion is between adjusting parameters within a given structure and questioning the structure itself. A well-calibrated model on a wrong structure is still wrong. Model risk is not about bad estimates. It is about choosing the wrong functional form. Model risk arises when the model structure is misspecified. Structural misspecification means the mapping from inputs to outputs is fundamentally wrong. No amount of parameter tuning corrects a structural error. The model can fit historical data and still systematically fail on new inputs. The failure mode is invisible within the model's own framework. Parameter uncertainty is bounded. Given enough data, parameters converge. Structural uncertainty does not converge with more data. If the structural form is wrong, more observations reinforce the wrong structure. This is what separates structural uncertainty from ordinary estimation error. More data resolves the latter. It cannot resolve the former. Optimization amplifies structural errors. When a system optimizes within a misspecified model, it moves toward what the model identifies as optimal. The true system has no reason to agree. The more precisely a system is optimized, the more precisely it is aimed at the wrong target. High optimization fidelity inside a wrong structure worsens the outcome. A model can pass every goodness of fit test and still be structurally wrong. Validation measures how well the model reproduces the data used to test it. It does not measure whether the assumed structure is correct. Two models with different structures can produce indistinguishable fits on any finite dataset. Structural uncertainty is not resolved by in-sample validation. Structural failure is often invisible until the regime changes. When a model is fit in one regime, it captures regularities of that regime. A regime change alters the underlying structure. The model continues to produce outputs, but those outputs describe a regime that no longer exists. Structural failure arrives precisely when it is most costly. Model risk is not managed by calibration. It is managed by structural humility. Structural humility requires maintaining multiple hypotheses rather than committing to one. It requires preserving optionality against structural failure. Model validation is evidence of past fit, not proof of structural correctness. Treating your model as true eliminates protection against the regime you cannot see.